In this session, let us solve a numerical problem on the load flow analysis of a 4-bus power system using Gauss Seidel method or GS method. This Gauss Seidel method is an iterative method. Iterative methods are used to solve nonlinear equations. In the iterative method, we start with an assumption or we start with a guess. For example, the bus voltage V3 equals 1 plus J0. This is my assumption. At the end of the first iteration, this bus voltage will be modified or this bus voltage will be updated. So at the end of the first iteration, we get closer to the actual voltage by one step. At the end of the second iteration, again the voltage will be modified or again the voltage will be updated. At the end of the second iteration, we get closer to the actual voltage by one more step. So the more the number of iterations, the more the accuracy of your solution. So usually we use digital computers to perform these iterative methods. So we can conduct some 100 or 250 number of iterations. So we will be very close to the actual voltage. But here we have to find out the 4 bus voltages V1, V2, V3 and V4 at the end of first iteration. There are mainly 3 types of power system buses. The first one is a slack bus or a reference bus. The second one is a PV bus or a generator bus or a voltage controlled bus. And the third one is PQ bus or a load bus. In the power system load flow analysis, we mainly deal with 4 parameters: magnitude of the bus voltage, angle of the bus voltage, P and Q. Out of the 4 parameters, 2 parameters will be specified at each bus. The remaining 2 parameters we have to find out. In the case of slack bus, both the magnitude and the angle of bus voltage will be specified. So we have to find out P and Q. In the case of PV bus or a generator bus or a voltage controlled bus, as the term suggests, P and V are specified. So we have to find out delta and the reactive power Q. In the case of PQ bus or the load bus, as the name says, P and Q are specified. So we have to find out V and delta. We look at this problem. The first bus is a slack bus. So both the magnitude and angle of the bus voltage is specified. We have to find out P and Q. The second bus is a PV bus or a generator bus or a voltage controlled bus. So here P and V are specified. We call it voltage controlled bus or a generator bus because the voltage is maintained at 1.07 voltage, because we assume that this generator or the generator connected at the second bus is having sufficient reactive power generation to meet the demand. And these 2 buses are of PQ type. So P and Q are specified. We have to find out V and delta. Let us first find out the bus admittance matrix. The transmission line impedances are given in the problem. This is the resistance, this is the reactance. What is Z12? Is the impedance of the line connecting buses 1 and 2. The resistance is 0.05 plus the reactance is 0.15. All these values are in per units. This is in per unit. This is per unit. All these parameters are in per units. So the admittance the line admittance equals 1 by impedance. This is equal to 1 by 0.05 plus j 0.15, and this is equal to 2 minus j6. Let me mark the value here. It is 2 minus j6. Z13 equals 0.1 plus j 0.3. Y13 equals 1 by Z13. This is equal to 1 by 0.1 plus j 0.3. So this is equal to 1 minus j3. Let me mark the value here. Now Z14 equals 0.2 plus j 0.4. Its admittance equals 1 by impedance. This is equal to 1 by 0.2 plus j 0.4. This is equal to 1 minus j2. Let me write the value here. It is 1 minus j2. The next line is the line connecting buses 2 and 4. Z24 equals 0.1 plus j 0.3. Its admittance equals 1 by impedance. This is equal to 1 by 0.1 plus j 0.3. So this is equal to 1 minus j3. Let me write the value here. 1 minus j3. Z34 equals 0.05 plus j 0.15. Its admittance Y34 equals 1 by impedance. This is 1 by 0.05 plus j 0.15, and this is equal to 2 minus j6. Let me write the value here. It is 2 minus j6. These are the line admittances. Now let us find out the bus admittance matrix. Y bus equals this is a 4 bus power system, so we will get a 4 cross 4 matrix. If we have a 3 bus system, the matrix will be 3 cross 3. So this is, the elements are Y11, Y12, Y13, Y14. The second row is Y21, Y22, Y23, Y24. The third row is Y31, Y32, Y33 and Y34. The fourth row is Y41, Y42, Y43 and Y44. Now let us find out the elements in the Y bus. What is Y11? Is the total admittance connected to the first bus. So these are the 3 lines connected to the first bus. This is how we find out the diagonal elements. So what is Y33? The total admittance connected to the third bus. So this is total admittance or sum of the admittances connected to the first bus. Sum of admittances connected to the first bus. So these 3 elements are connected to the first bus. So what is the total admittance? Add the real parts together. 2 plus 1 equals 3 plus 1 equals 4. So this is 4. Add the imaginary parts together. 6 plus 2, it is 8 plus 3, it is 11. So it is 4 minus j 11. Now let us find out this off-diagonal element y12. This is the negative of the admittance connected between bus number 1 and bus number 2. So it is minus of 2 minus j6. So this is minus 2 plus j6. This is how we find out the off-diagonal element. Negative of admittance connected between bus number 1 and bus number 2. So what is y41? The negative of admittance connected between bus number 4 and bus number 1. Now let us find out y13. Negative of admittance between bus number 1 and bus number 3. Minus of 1 minus j3. So it is minus 1 plus j3. y14. Negative of admittance between bus number 1 and 4. Minus of 1 minus j2. So this is minus 1 plus j2. y21 is same as y12. So this is minus 2 plus j6. y22 is the total admittance connected to the second bus. These two lines are connected to the second bus. The total admittance is, add the real parts together, 3, add the imaginary parts together, minus j9. What is y23? There is no element between bus number 2 and 3. So this is 0. What is y24? Negative of admittance between bus number 2 and 4. So it is minus of 1 minus j3. So it is minus 1 plus j3. Now y31 is same as y13. So what is y13? It is minus 1 plus j3. y32 is same as y23. So y23 is 0. So this is also 0. What is y33? Total admittance connected to the third bus. This is the third bus. These two lines are connected to the third bus. Add the real parts together. Add the imaginary parts together. 3 minus j9. What is y34? The negative of admittance between bus number 3 and 4. Minus of 2 minus j6. So it is minus 2 plus j6. y41 is same as y14. So this is minus 1 plus j2. y42 is same as y24. So this is minus 1 plus j3. This is y43. This is same as y34. So this is minus 2 plus j6. What is y44? Total admittance connected to the fourth bus. These three lines are connected to the fourth bus. Add the real parts together. 2 plus 1 equals 3 plus 1 equals 4. Add the imaginary parts together. 6 plus 2, it is 8, plus 3, it is 11. So it is 4 minus j11. So this is the bus admittance matrix. Now let us write the given parameters of this problem. Let us write all the voltages, active power and reactive power given in this problem. These are the 4 buses we have. Let me write the initial values as 0th iteration. Later on we will find out the bus voltages at the end of first iteration. The initial values are marked as 0th iteration. We have 4 buses, V1, V2, V3 and V4. These are the 4 bus voltages. As it is the 0th iteration, let me mark this as V1 0, V2 0, V3 0 and V4 0. The superscript 0 represents the iteration number. The subscript 1 represents the best number. So what is V40? The fourth best voltage in the 0th iteration. What is V10? The first bus is a slack bus. So both magnitude and angle of bus voltage is specified. So it is 1.05 angle 0. Or you can write this as 1.05 plus J0. What is the second bus? This is a PV bus. So P and V are specified. The magnitude of bus voltage is 1.07. This is 1.07. Angle is not given in the question. We have to find out the angle. But as it is an iterative method, we have to assume a value. Let me assume that this is 0. This is my assumption. This is not the given value. This is assumption. So we will find out this delta in the first iteration. This can also be written as 1.07 plus J0. And P is also given. What is P2? Because it is a PV bus. P equals 0.5 per unit. So this is 0.5 per unit. What is V30? Third and fourth buses, both are of PQ type. So the voltage is not given in the question. We have to assume a voltage. Let me assume this is 1 plus J0. This is called flat start. 1 plus J0 is called flat start. The fourth bus voltage is also assumed as 1 plus J0. This is called flat start. Now the third bus is PQ bus. So P and Q are given in the problem. P3 equals minus 1. And Q3 equals 0.5 per unit. What is P4? The fourth bus active power is 0.3. And Q4 equals minus 0.1. So these are the given parameters of this problem. And the reactive power constraint of the generator bus or the second bus is given. It is 0.4 less than or equal to Q2 less than or equal to 1 per unit. The lower limit is set at 0.4 because of the stability problems. This generator can produce a minimum reactive power of 0.4 per unit. It cannot generate a reactive power less than 0.4. If we force the generator to produce a reactive power less than 0.4, the stability of the machine will be affected. This can produce a maximum reactive power of 1 per unit because of the rotor overheating. If this machine is forced to produce a reactive power more than this 1 per unit, then the rotor of the generator will be overheated. So these are the constraints of our generation, reactive power generation. This is 0.4 less than or equal to Q2 less than or equal to 1 per unit. This is the reactive power constraint. At this second bus, because the second bus is a PV bus or a generator bus or a voltage controlled bus. Now let us find out the 4 bus voltages in the first iteration. What is V1? These are the bus voltages we are going to find out at the end of first iteration. What is V11? The first bus is slack bus. Both the magnitude and angle of bus voltage is specified. This voltage will never change. Whether it is the first iteration or the 100th iteration, this bus voltage will remain the same. This is equal to 1.05 plus J0 or 1.05 angle 0. What about the second bus? The second bus, the magnitude is given. This is the given value. In the first bus, both magnitude and angle are specified. In the second bus, the magnitude is given in the problem. So this is 1.07 angle we have to find out. What about the third bus and the fourth? They are the PQ buses. We have to find out the voltages. Now we have to find out this angle delta of this second bus. In order to find out this angle, we will find out a temporary bus voltage V2. So V2 equals, we will get a magnitude and angle. From this, we will take only the angle delta 2 because the magnitude is already specified in the problem as it is a PV bus. Now let us find out the reactive power of the second bus in order to find out the bus voltage V2. The reactive power Q2 equals minus imaginary part of V2 conjugate into Y21 V1 plus Y22 V2 plus Y23 V3 plus Y24 V4. Here we consider all the elements in this second row. When you find out the reactive power at the second bus, we consider all the elements in this second row. Y21 V1 plus Y22 V2 plus Y23 V3 plus Y24 V4. Now this is equal to, when you write the voltages, you have to write the updated voltages available, or you have to write the latest voltages available, because the first iteration voltages are more accurate when compared to the 0th iteration voltages. The second iteration voltages are better than the first iteration voltages. Now V11 is available with us. This is our V11. So where should we choose V10? This is the best one. When the best one is available, you choose the best. So this is V11. We have to write V11. What about V2? V21 is not available with us because delta is not given to us. So only V20 is there. So you choose that value V20. What about V3? V31 is not available. Only V30 is there with us. So you choose V30. What about V4? V41 is not available. Only V40 is there. So you choose V40. So this is equal to minus imaginary part of, what is V20? It is 1.07 plus J0. Its conjugate is 1.07 minus J0 into Y21 minus 2 plus J6 into V11. It is 1.05 plus J0 plus Y22 V20. Y22 equals 3 minus J9 into V20. It is 1.07 plus J0 plus Y23 V30. Y23 equals 0 plus Y24 V40. This is Y24 minus 1 plus J3 into V40, 1 plus J0. So this is equal to minus imaginary part of 1.07 into, the first term equals minus 2.1 plus j 6.3 plus the second term equals 3.21 minus j 9.63. The third term is 0. The fourth term equals minus 1 plus j3. And this is equal to minus imaginary part of 1.07 into 0.11 minus j 0.33. And this is equal to minus imaginary part of 0.1177 minus j 0.3531. And this is equal to, this is the imaginary part minus of imaginary part. This is 0.3531 per unit. This is the reactive power demand at the second bus. But unfortunately, the second bus cannot produce this reactive power. This is the lower limit of the reactive power which can be generated by the second generator. So it cannot produce 0.3531 per unit. We call the second bus as a generator bus or a voltage controlled bus because the voltage of the second bus can be maintained at 1.07. This is the desired voltage. This can be maintained at 1.07 because of the sufficient reactive power generation at the second bus. But now, unfortunately, this machine cannot produce the sufficient reactive power. This is my demand, 0.3531. But this machine cannot produce 0.3531 per unit reactive power. So if the machine violates the reactive power demand, then this machine cannot be considered as a PV bus, or this cannot be considered as a voltage controlled bus. Now this will automatically become the normal PQ bus. Now we have to set the reactive power at Q2 equals at its lower limit, 0.4. This is the minimum value of reactive power the machine can produce. If the demand is less than the lower limit, then you set the reactive power at its lower limit. If the demand is more than the upper limit, then you set the reactive power at its upper limit. Because this is the minimum reactive power this machine can produce. So now this voltage is no more 1.07 because it cannot control the voltage or it cannot maintain the voltage at the desired value of 1.07. It can maintain the voltage at 1.07 only if the machine is able to produce the sufficient demand. Now this voltage is no more equal to 1.07. When it violates the reactive power demand, the reactive power constraint, so this voltage cannot be produced. So I have to treat this as a load bus. So just start with the 1 plus J0. You have to assume the flat start here also. Now P and Q are given. Let us find out the second bus voltage. Let us find out V2. We consider this as a load bus. So this is not 1.07. We will find out both magnitude and angle of the bus voltage, just like a PQ bus. So what is V2? V2 is equal to 1 by Y22 into P2 minus JQ2 divided by V2 conjugate minus Y21 V1 minus Y23 V3 minus Y24 V4. Here we do not consider the diagonal element Y22. We write all the terms except the diagonal element. Y21 V1 y23 v3 and y24 v4. We consider all the elements in this second row except the diagonal element. Now here also when you substitute the voltages, you should substitute the updated voltages. If the voltage in the first iteration is available, you choose that voltage, because this is better than the 0th iteration voltages. So V11 is available. What about V2? V21 is not available, only V20 is there. So this is V20. V30 is there with us. V31 is not available. V41 is not available, only V40 is there. So I choose V40. So this is equal to 1 by Y22 equals 3 minus J9 into P2 minus JQ2. P2 equals 0.5 minus JQ2, J 0.4 divided by V20 conjugate. It is 1 plus J0. Its conjugate is 1 minus J0 minus Y21 V11. Y21 is minus 2 plus J6 into V11 1.05 plus J0 minus Y23 V3. Y23 is 0 minus Y24 V4. Y24 is minus 1 plus J3 into V40 is 1 plus J0. So this is equal to 1 by 3 minus J9 into 0.5 minus J0.4 minus this term equals minus 2.1 minus J 6.3. The second term is 0 minus the third term is minus 1 plus J3. And this is equal to 1 by 3 minus J9 into, this is 3.6 minus J 9.7. And this is equal to 1.09 plus J 0.0367 per unit. In the polar form, this is equal to 1.09 angle 1.93 degree. Now let me write the voltages here. So V21 equals 1.09 plus J 0.0367 per unit. In the polar form, this is equal to 1.09 angle 1.93 degree per unit. Now let us find out V3. V3, this is the third bus voltage. The third bus is a PQ bus. So V3 equals 1 by Y33 into P3 minus JQ3 divided by V3 conjugate minus, here we are finding out the bus voltage, the third bus voltage. So we consider all the elements in the third row except the diagonal element. This is our diagonal element. So which are the terms we consider? Except diagonal element, all other elements we consider Y31 V1, Y32 V2 and Y34 V4. Y31 V1 minus Y32 V2 minus Y34 V4. So this is equal to, here when you write the voltages, you should write the updated voltages. V11 is available with us, so you choose V11. What about V2? V21 is there with us. So you choose V2 1. What about V3? V3 1 is not with us. Only V3 0 is there. So you choose V3 0. V4 1 is not with us. Only V4 0 is there. So you choose V4 0. So this is equal to 1 by, what is Y33? It is 3 minus J9 into P3 minus JQ3. P3 equals minus 1 minus JQ3. It is 0.5. Divided by V30 conjugate. It is 1 minus J0 minus Y31 minus 1 plus J3 into V11 1.05 plus J0 minus Y32 V2. Y32 equals 0. Y34 V4. So Y34 is minus 2 plus J6 into V40 1 plus J0. So this is equal to 1 by 3 minus J9 into minus 1 minus J 0.5 minus the second term equals minus 1.05 plus J 3.15. This term is 0. The last term is minus 2 plus J6. So this is equal to 1 by 3 minus J9 into 2.05 minus J 9.65. And this is equal to 1.033 minus J 0.11667 per unit. In the polar form, this is equal to 1.039 angle minus 6.44 degree per unit. Let me write the third bus voltage here. V31 equals 1.033 minus J 0.1166 per unit. In the polar form, this is equal to 1.039 angle minus 6.44 degree per unit. Now let us find out V4. V4, the fourth bus voltage in the first iteration. The fourth bus is also PQ bus. V4 1 equals 1 by Y44 into P4 minus JQ4 divided by V4 conjugate minus, when you find the fourth bus voltage, we consider all the elements in the fourth row except this diagonal element. You have to consider all the elements in the fourth row except diagonal element. So the terms are Y41 V1, Y42 V2 and Y43 V3. This Y41 V1 minus Y42 V2 minus Y43 V3. This is equal to 1 by Y44 equals 4 minus J11. It is 4 minus J11. P4 minus JQ4. It is 0.3. Q4 equals minus 0.1. Divided by V4 conjugate. It is 1 minus J0. Minus Y41 V1. This is Y41. It is minus 1 plus J2 into V1. So here also we should write the updated voltages available. Here V1 1 is available with us. So you choose V1 1. You should not choose V1 0. V2 1 is available with us. So you should choose V2 1, not V2 0. And V3 1 is available, you choose V3 1. But V4 1 is not available with us. Only V4 0 is available. So choose V4 0. So that's why this 1 minus J0 is written here. What is V1 1? 1.05 plus J0 minus Y42 V2. This is Y42 minus 1 plus J3 into V2 1 equals 1.09 plus J 0.0367 minus Y43 V3. This is Y43 minus 2 plus J6 into V3 1 equals 1.033 minus J 0.1166. And this is equal to 1 by 4 minus J11 into 0.3 plus J 0.1 minus the first term equals minus 1.05 plus J 2.1 minus the second term equals minus 1.2001 plus J 3.233 minus the last term equals minus 1.367 plus J 6.433. And this is equal to 1 by 4 minus J11 into 3.9171 minus J 11.666. And this is equal to 1.05105 minus J 0.026. In the polar form, this is equal to 1.054. It is 1.0514 angle minus 1.42 degrees. This is the fourth bus voltage. Let me write the voltage here. It is 1.05105 minus J 0.026. In the polar form, this is equal to 1.0514 angle minus 1.42 degrees per unit. So these are the four bus voltages at the end of the first iteration.